Okay, so today we're going to be talking about trigonometry. So trigonometry is the study of triangles and trigonometric. Now y'all got me someone. And trigonometric functions. Okay, so using sine, cosine, or tangent, you can find missing angles or side lengths of right triangles. Guys, everything we're doing today is based on it being a right triangle. Okay, so don't go home and try this with not right triangles.
Like I go home and try
Okay, so we're going to try to fix this. Alright, sine is opposite over hypotenuse.
opposite over hypotenuse or opposite of?
Over. It's a ratio, so we're setting it over. Okay, so we're going to create this right triangle. We have triangle A, B, C. Angle B is my right angle. Okay, so if I was trying to find sine A, that's the ratio of the side opposite to the hypotenuse. So what's the side opposite? And what's the hypotenuse? AC. If you're at angle A, you're going opposite and hypotenuse. No. It's the opposite of the angle. Over the hypotenuse of the triangle. So sine C, let me switch colors here. AB over here over AC. So your sine ratio is setting up the opposite side over the hypotenuse. So cosine is another ratio we can set up. Cosine is comparing or setting up your adjacent side to the hypotenuse. So again, if we drew this out, ooh, that's a pretty long one. A, B, C, here's my right angle. If I were to ask for the cosine of A, which side is adjacent to angle A? AB. What is the hypotenuse? AC. Yeah, we're not using the hypotenuse as an adjacent or an opposite. Okay. Cosine C would be what? Yeah, BC over AC. Anyone see any common? What do you mean? So sine A is the same as cosine C? And sine C is the same as cosine. Hey. So sine B would be hypotenuse over hypotenuse, which is what? 1. So yeah, if you were to put sine of 90 degrees into your calculator, you would get 1. Mm-hmm. Okay, let's think about this. If I had cosine, let's say cosine with C, let's say C was, oh, I don't know, 43 degrees. So cosine C is 40, so cosine of 43 degrees equals the sine of what? What would A have to be?
47 degrees.
Would be what?
No, 47.
Why 47? So you're basically finding the complementary angle here, right? So you're saying that the cosine of an angle is equal to the sine of its complementary angle. Let me say that again. Cosine of an angle is equal to the sine of the complementary angle. Okay, so our last ratio is tangent. So we've done opposite over hypotenuse, we've done adjacent over hypotenuse. Now we're doing opposite over adjacent.
I actually don't answer that question. It'll probably be confusing.
Okay, so I'm setting up my triangle A, B, C. So if I were to find,
Instead of putting letters, could you do like cool symbols?
yeah, so
I'm doing that.
if I did, a lot of times, they denote angles with the Greek symbol theta. So guys, that symbol is just theta. A lot of times they use that for an angle, the measure of degrees. Yeah, I mean, it's a Greek letter. So the tangent, let's say, you could have said, let's say theta. Let's say tangent of theta if y'all want to use symbols. Okay. Or if you want to use A, that's fine. I'm talking about the same thing. I'm talking about this angle right here. Okay? What's the opposite segment? What's the adjacent segment?
Wait, so to find the opposite segment, do you just draw a line from the angle down to the earth?
Exactly right. What side is opposite?
So they're just gonna flip that?
Yep.
Cross.
These are just going to be opposite of each other.
Luke. They're just gonna flip the
It's star swirl over star heart.
They're just gonna flip
No,
the sign.
yeah. Swirl heart.
You just draw swirl every time.
All right.
It's like miniature man with no file.
So one common way that people like to memorize these is SOHCAHTOA. Or some people make up little like mnemonic tricks like some old horse caught a horse taking oats away. Like some old horse caught a horse taking oats away. SOHCAHTOA is a common way of saying that. Those are, if you looked online, there'd be a million different little memory devices to remember the relationships that are going on here. So let's put these into practice. Okay? So let's put this into practice. So let's say we have a triangle, and let's do a 9, 12, 15 triangle. Okay. Well, we're about to find the angles. Yep. So I'm going to say that this is A, this is B, this is C. Okay, so let's find the sine of A. What would that ratio be? Opposite over hypotenuse, so 12 over 15. Let's do the tangent of C. Okay, let's do the cosine of C. Okay, so we're gonna find angle A, and then two different ways we'll find angle C. So, ready? So these are operations that are happening to the angle. That's the ratio that's being set up. Okay? The angle is not 12/15. Okay, that's not the measure of the angle. That's the proportion we're putting it in. So to undo that, we have to do inverse sine of sine A. Inverse. And inverse sine of 12 over 15. Okay. So all you have to do is A is the inverse sine of 12 over 15. So this is where we go to our calculators. In your calculators, hit the blue second button and then hit sine. What do you see? Yeah, inverse sine. Then in the parentheses, do 12 divided by 15. So what do you see? 53.13 degrees. Again, make sure that your mode was set to degrees, not radian. But how would we do the tangent here? Yeah, you could just go ahead and skip down to C equals the tangent inverse of 9 over 12. So second tan, and then 9 divided by 12. So that would be 36.87 degrees. All right, and then we're going to find C one more way using cosine. So C would be the inverse cosine of 12 over 15. So do inverse cosine of 12 over 15. What do you get? What do you get? 36.86989765. So again, 36.87 degrees. Yes, this is calculator required. Yes. So this is setting up. We're going to do more angles tomorrow, and we're also going to be able to find if you had a missing side length tomorrow.